Okay guys, so we're going to work on bell work for week 4. I'm gonna do something different this week. Make sure you take notes. I am writing in a separate sheet of paper because I need you guys to take notes. Like always, these are supplemental videos for what we go through in class. But make sure you take notes so you know how to do the whole week. Be careful because the examples that I'm doing on my notes are different to the ones that are on Monday's bell work. So do not rely on these examples to do Monday's bell work. Okay? So I'm gonna put a title as bell work week 4. These are my notes. So the first one that it says simplify the expression. So the example that I'm going to use is different than Mondays or any other day. So make sure you follow my instructions but not the numbers. So I know we have a lot of binomials, but I know that between this binomial and this binomial there is a multiplication because there's nothing in between. And between these ones and that one there is a subtraction. So there's two things that we need to do. And like always, if you guys need extra space, make sure you get an extra sheet of paper to do all your work. Don't try to jump everything in there because sometimes it doesn't fit. Okay, so like I was saying, first we have to do this multiplication of binomials. Whenever we see a multiplication, we automatically have to think about the area method. And I have my little box. I'm going to zoom in. So we write one of the binomials horizontally and we write the other one vertically. Like always, I like to keep my signs so I know these are positive. So remember, if we're looking at this box right here, we multiply this number to the left by the number on the top. So we have 6x squared. The exponent is because we're multiplying two x's. Bottom is 5 times 3x, which is 15x. Top right is 2x times 2, which is 4x. And then the bottom is 5 times 2, which is 10. After that, we're going to rearrange it. So what I'm going to do, we usually do our loop thingy. So I'm just going to rearrange it. I'm going to do that commutative property. So I'm going to bring down my 6x squared. I'm going to bring down my plus 15x. I'm going to bring down my 4x, and it's a positive, and then my 10. After that, this loop, what this means is pretty much that these two are like terms, and we're going to keep them together. So rewriting this to 6x squared, this two goes together, so it plus 19x, and then we bring down the 10. Alrighty, we are not done because if you remember the original expression, we just took care of this. We need to take care of that. So we're going to bring down the minus 2x plus 8. If you remember from week 1 and week 2, whenever we have a negative in front of a parenthesis, this negative is going to affect the terms that are inside. And when I say affected, it's going to flip the sign. So if this is a positive 2x, this negative is going to make it a negative 2x. If this is a positive 8, this negative is going to make it a negative 8. Make sure when we do the distributive property or the negative distributive property, we do it evenly. So if we do it to the first one, we have to do it to the second one, or how many terms we have inside the parentheses. The next thing that I do is we bring down what we already have, 6x squared plus 19x plus 10. After that, we could rearrange it, or we can separate our like terms. Remember, what makes it like term is the fact that the variable and the exponent are the same. So there is no other x squared in all these numbers. We go to the next one. There's one x, negative 2x has an x, so we're going to keep them together. 19 minus 2, it's 17, so it's 17x. We know that this 10 is a constant, and this negative 8 is a constant, so we keep them together. Plus 10 minus 8 is plus 2, and that is the answer of our expression. Like I said, I know it's a lot of work for this little tiny square, so if you guys want to use a separate sheet of paper, you can always do that. Make sure you show me your work so I know you understood how to do it. So number 2, it says solve the equation for x. We've done this before. Use this note right here. Number 2. Solve the equation for x. Alright, like I was saying before, remember these are different numbers, so do not copy this on Monday's bell work, okay? So we have 4x minus 6 equals 34. We need to solve for x, therefore we need to have x by itself. And first we need to put together like terms. We know 6 and 34 are like terms, and the way we send this to the other side is according to the EOC. We do the addition property of equality, meaning we're gonna bring down what we have, and because the 6 is subtracting for x, the opposite of subtraction is addition. And what happens to the left of the equal happens to the right. So we bring down the 4x, negative 6 and 6 cancel each other. We bring down the equal, 34 plus 6 is 40. Then we do not leave it like that because we still don't have x by itself. We know 4 is multiplying x. The opposite of multiplication is division, and what happens to the left of the equal happens to the right. 4 over 4 equals 1, does not mean 0, equals 1. So we just bring down the x, because remember there is an invisible 1 in front of the x, equals 40 divided by 4 equals 10. Alrighty. I'm going to use the back of my paper to do the next one. Right here it says simplify by writing an equivalent radical expression. Okay. We did that last week, so it's a kind of a review. So let's go to number 3. Alrighty, I just wrote what it says up here on the exercise. So The number that I'm going to use is a square root of 45. So according to our notes from last week, the first step that we do is we find the factors of 45. So we know that 1 times 45 equals 45. 45 divided by 2, we cannot have that. 45 divided by 3, it's 15. 45 divided by 4 is none. 45 divided by 5 is 9. So I'm going to stop there for the time being, and we're going to see that the step number 2 in rewriting an equivalent radical expression is to find out of all these numbers which one has a set that has a perfect square. Remember, a perfect square is any number that has a square root. Okay, so 45 doesn't have any, 3 doesn't have any, 15 doesn't have any, because remember guys, square root of 45, nope. Square root of 3, nope. Square root of 15, nope. Square root of 5, nope. Square root of 9 is 3. So we know that this is a set. So we circle the set of factors that one has a perfect square. Step number 3, we write it under the radical. Please do not forget about your coefficient. Okay? So this is the same thing as writing 8 times 5 times square root of 9. It is the same thing. I just split it. So we, like we said earlier, the square root of 5 is a funky number. So we leave it as it is. So we're going to bring down the 8 and we're going to bring down that 5. But we know that the square root of 9 is 3. So we are not done yet because we have the coefficient and the perfect square. When we have these two numbers outside the radical, these two multiply. Because remember, 8 is multiplying square root of 5, and then they are multiplying 3. So 8 times 3 is 24. We bring down the square root of 5, and that is your simplified version of the equivalent radical expression of 8 square root of 45. Okay? Last but not least is this word problem right here. 100 students were asked which fruit or veggie they would prefer as a side item for lunch. All rows should equal the total, and all columns should equal the total. Okay, so like I said, I am going to use a different example. So I'm still going to use 100 I want to say adults were asked what kind of car, what color, and car model they like. Okay, so I'm gonna create a similar chart like that one. So okay, so I'm gonna use black, white, total, and I'm gonna say Honda, Toyota, and total. So it's kind of the same as the one that we have, the table that we have over here. Okay, so that example is giving me numbers on these two columns. So I'm going to put 21 here, 13 here, 23, 43, 44, and 56. To explain this is 21 adults like black Hondas, 23 adults like black Toyotas, 13 adults like white Hondas, 43 adults like white Toyotas. The total of adults that like black cars is 44. The total of adults that like white cars is 56, because 13 plus 43 is 56. 21 plus 23 is 44. Therefore, if we add these two and it gives me the total, these two and it gives me the total in the columns, it's still going to happen the same way in the rows. So we can say that 21 and 13 adults like Hondas. So the total of adults out of those hundreds adults is 21 plus 13, it's 34. So I can say that 34 adults like Hondas out of those hundreds adults. And then 23 plus 43 is 66. So I can say that 66 out of those 100 adults like Toyotas. If we add these two numbers and these two numbers, they have to give you 100. So 34 plus 66 equal 100, because I did 34 plus 66, and 44 plus 56 equal 100. So these tables is to help you understand that, for example, if I want to know how many adults like white Toyotas, we know that 43 like white Toyotas. Okay, 56 like white cars, 44 like black cars. So, alrighty. So whenever you do Monday's bell work, make sure you do not copy what I just wrote down. Make sure you use it as a guide to do your Mondays and the whole week's bell work. Let me know if you guys have any questions.